Alright, so in section 10.7, which is the last section of this chapter, we're going to take a look at algebraic equations of circles. So now we are actually going to place our circles on a grid where we have x and y axes. So the first thing I'm going to do is use Desmos to graph a circle. And in order for us to get a circle, we would need an x squared plus a y squared. And we need to pick a radius, so I'm just going to do 1 squared. So what this is saying is that we have a circle which is centered at 0, 0, and it has a radius of 2. Now, if I wanted to move my circle horizontally, then what I would need to do is I would need to play around with my x coordinate, because that is what is going to affect my horizontal shift. So if I want to move my circle to the right, I'm actually going to subtract. So let's say I wanted to move it right 5. So my blue circle is the new one. The center got shifted to the right 5 units. Now if I want to shift my circle up or down, I have to play around with my y coordinate. So if I want to move my circle downwards, I'm actually going to add, let's say 3. So what I essentially did is I moved my circle 5 to the right and 3 down. So everything is opposite of what I'm typing in. Now right now I haven't played around with my radius. So I'm going to take a look at how to make my circle bigger. Currently my radius is 1. If I want to change my radius, I am going to change this number to the right of the equal sign. So let's say if I want my radius to have a radius of 3, I'm going to say 3 squared. So my green circle has a center at 5, -3, and it has a radius of 3. So I'm going 3 units away from the center to sketch it. And these are written in the standard form of the equation for circles. Okay, so now we're gonna take some notes. So basically, I'm gonna generalize it, and what I'm gonna do is I'm just gonna say that my circle has a center, and I'm gonna use AB, right? Where A is the x coordinate, B is my y coordinate, and I'm gonna say it has a radius of r. So in standard form, I know that I'm gonna need an x, I need a sum, I need a y, I need to square it, and it's going to be equal to radius squared. So I'm always going to have the opposite. So if my center is at A, I will need minus A, and if my center is at B for the y coordinate, I need to have the opposite. And if my radius is r, I'm going to square that number, and that's how I'm going to get the radius. Now, keep in mind that when I actually know the radius, we are going to simplify the number. Okay, so let's pretend for a second that we have this circle where we have the graph, and we have to write the standard form of the equation. I need to know 2 pieces of information. I need to know my center, and I also need to know my radius. And my center, I'm going to read straight from the graph. So my center is going to be right here, equally away from all the points of my circle. So my center is at 2, 3, meaning that I shifted everything 2 to the right and 3 up, right, because it used to be at the origin. And my radius will be the length, right, so how far did I go from the center to the furthest point? So it looks like I went 4 boxes. So when I need to write my equation, remember it has to be in standard form, so I'm going to set up my little template. Okay, so if I wanted to shift 2 to the right, I need to subtract 2. And if I want to shift my center up 3, I need to subtract 3. And if my radius is 4, this right here needs to be that number squared. right? And when we write our standard form, we always want to make sure that it's simplified. All right, let's do one more. I need to know my center. So in this case, my center is at 4, 4. And I also need to read off my radius. So my radius is going to be 1 unit. So when I write my standard equation, again, I'm going to make my little template. I will always need an x squared and a y squared in order to have a circle, and I always need a plus. So I shift to the right 4 units, I'm going to subtract 4. I need to shift up 4 units, I'm going to subtract 4. And my radius is 1, so if I square 1, I still get 1, right? So this right here is 1 squared. All right? So now we're going to go backwards. So now I'm going to give you an equation, and we are going to read the equation and graph it. Again, I need 2 pieces of information. I need to know where is my center. So if I replaced x with x minus 4, I went to the right 4 units. So my x coordinate is 4. And for the y, if this is y plus 1, it means that I actually went downwards 1. And if this is 9, remember that radius squared was 9, so I need to square root it to get back to my radius. So radius squared is 9, which means that my radius is 3. And now I'm ready to graph. So I'm going to locate my circle, or my center, and I'm going to go equally away 3 units. And the best thing we could do is kind of go 3 units up, 3 units to the right, 3 units to the left, and 3 units down. And we're just going to do our best and make it as circular as possible. Okay? All right. Let's do one more. So you are given the equation. We are going to read the center. So our center is at -2, -1. Because remember it was opposite, right? So this means I actually went left 2, and this means I went down 1. So I'm going to actually write that down. So left 2, and if I did +1, I actually went downwards 1 unit. Okay, and my radius squared is 12. So if I would like to get my radius by itself, I'm going to take a square root of it. So it's square root of 12, and I do want to simplify it so it becomes 2 root 3. Now, when I graph it, I do want to kind of ballpark approximately where it is for myself. So I do know that 12 is a little bit bigger than 9, so I know it's going to be 3 point something. And at this point, I definitely can use a calculator to get an idea of where it is. So it's like 3.5-ish. And this is just for me for the graphing purposes. So I'm going to locate my center, and I'm going to go about 3.5 boxes away. And again, we're going to do our best. Doesn't have to be perfect, but that's what it's going to be. Okay. Now the problem is that the equations are not always going to be given to us in standard form, right? So if it's standard form, we can easily read off from the equation the center and the radius, and we're good to go. However, sometimes they're given to us in this form. And in Algebra 1, we saw this a similar idea when we were working with parabolas, and it was not given to us in vertex form, and we had to complete the squares. So basically, the idea is that we want to rearrange this equation to make it look like this. This is our end goal, because then we would know exactly where the center is, what the radius is. So the first thing we're going to do is I'm going to rearrange my equation. I want all the x's to be together, and I want all the y's to be together. Notice I left some room, and you'll see in a second why. And I want all the numbers to be moved over to the right of my equal signs. I'm going to subtract 66. okay? And what we essentially want is when we factor, we want the parentheses to be the same so we can write it as a perfect square. So what I will want to do is I want to break up my middle term into two equal parts. I'm going to do the same thing. So 6y or negative 6y gets broken up into negative 3y and negative 3y. Okay. Now, what happens is when we complete the square, right? So completing means we actually are going to figure out what to add as the end in order to have a perfect square, okay? So we are going to remember that these two numbers multiply to the same as the outside number. So 11 times 11 is 121, right? And since my coefficient in front of x squared is 1, I know I need a 121. Now, I'm not allowed to randomly add 121. To the left side, we want things to stay equal, so I'm going to add a 121 to the right. Now, I'm going to do the same thing for the y's. I'm going to say, ask myself, what are these two multiply to? And they multiply to 9. And I want the same product for my outside number. So I have a 1 in front of y squared. So I just need a 9 or plus 9 as my last term. And as soon as I add a 9 on the left side, I'm going to add a 9 on the right side. Now that I have this, I can easily factor by grouping. Right, so these have 11 in common. And what you should notice is that we end up having the same x plus 11 twice. And that's exactly what we wanted, right? Because we wanted to write it as a perfect square, or like a quantity squared. Okay, for the y's, again, I'm going to do grouping. So I have this problem. My first group has a y in common. My second group has a negative 3 in common. Right, and they're all added. And we have y minus 3, y minus 3. So it's the same y minus 3 squared. So I already know my center is at negative 11, positive 3. And the only other thing I need to do here is I need to figure out my radius. So I very carefully have to double check, what do all of these numbers add up to? So I'm going to say 66, negative 66 plus 121 plus 9 gives me a 64. Now remember that 64 was radius already being squared. So if radius squared is 64, my radius would have to be square root of that. So it had to be 8. Right, so my directions said use information to write the standard form of the equation. So I am done. This is my final standard form. I'm going to do one more of these before we stop, just to make sure that we feel good about them. Okay. Remember, my end goal is to make my equation look like this. Okay. And what I'm going to do is I'm going to rearrange so all my x's are together and all my y's are together. And the numbers that don't have a variable are going to go to the right. Okay. Now what I'm going to do is I'm going to split my 24 x's into two equal parts. Right, so half of 24 is 12. So I'm going to break it up, and it still has to be negative. I'm going to come back to that. I'm going to do the same for my y's. So if I split it, I get negative 6y and negative 6y. And we're splitting it equally to make sure that we end up with the same two factors when we factor. Okay, so now we have to complete our perfect squares. So these two numbers multiply to 144. I want my outside numbers to multiply to 144. Since my coefficient of x squared is 1, I just need 144 at the end. And do the same. Oh, and very, very important, we have to make sure we don't forget to balance. Over here, these two numbers multiply to positive 36, so I need a 36 here. and I'm gonna add a 36 here. Very, very, very important. I'm actually going to even highlight this, right? So here's my 144. Here is my 144. Here is my 36. Here is my 36. Because if you forget, what's going to happen is your radius is going to be all messed up. Okay, so now that I have my 4 terms, I can easily factor, right? I'm going to factor by grouping. So I have x minus 12. I have negative 12, x minus 12. I get x minus 12 and an x minus 12, which is exactly what I wanted. So I get x minus 12 squared, quantity squared. And now I'm going to go back to my y's. Again, I turn this into grouping problems. So these have a y in common. My last 2 terms have a negative 6 in common. And just like I wanted, they are the same. All right. So now that I have my center, all right, the center is at 12, 6. I just need to figure out my radius. So my radius is going to be, let's see, we're going to take negative 155, we're going to add 36, and we're going to add 144, and I got 25. So if somebody asked me for a center, I would say that it is 12, 6. And if somebody asked me her radius, I would say that it's 5. So that is the end of the 10.7 lesson that deals with circles and the standard form of the equation for circle.